So if an object is moving in a circle, if we trace a path from the center of the circle to where an object is at specific points in time, it will subtend a certain angle. As it says here, it subtends or opens an angle of omega t every t seconds. So this is the Greek letter omega. It sort of looks like a funny W. I will always try to differentiate my omegas from my W's. I will make my omegas with a little hook, whereas my W's won't have the hook. Even though that actually looks more like an omega, but nonetheless. So omega is the magnitude of the angle opened or subtended per second. So therefore the angle opened in t seconds is omega t. Omega is measured in radians per second. However, radians is considered dimensionless, so we can write omega in units of just per second. Now when we get to waves, this is not the same as frequency per second, because frequency, there's a hidden unit of what's known as cycles in here, and of course the hidden unit of radians in here. But it is perfectly acceptable to write answers of omega in terms of just per second. We can actually find the linear speed of an object in terms of its angular speed. If omega is theta over t, so angle turned or subtended over time, and if we go from L equals r theta, we get that theta is L over r, which is this relationship here. So if we substitute that in, we get omega is L divided by RT. But we know that the velocity, linear velocity of an object is distance over time, so length is a distance because length is never negative. So omega is therefore v divided by r, which is often written as v equals omega r, which is a slightly more common way of representing omega. However, still having omega as even d theta by dt, so the instantaneous angular velocity is the derivative of angle over time, is still fairly commonly used, but you will come across v equals omega r a lot more.